Hi everyone! Today I want to share with you this project you are seeing now behind of me. If you want to build a neon light like this one, it's not difficult. You only need some components that you can easily find online and a 3D printer. Let's start from the beginning. All began when I was web searching and found some components that were really interesting. It has been some time that I want to test these fiber optics cables and LEDs that you usually use to do internal car illumination, and they seem quite simple. So you just attach the fiber optics on the LED light and you power on. As this is made for use on cars, it will use 12 volts. I am connecting now the positive, the red one, and the negative, the black. Yeah, connected. Let's power on and see how much bright that it is. Oh, not bad. Not bad at all. Let's turn off the lights. Yeah, I can see some news of that. Not for my car though. I think I have a really other good use for that. Brain. Yeah. How about make a brain, a neon light in a shape of a brain? So for that I found this brain image on internet, and I using Affinity Designer to draw a line, and that line will be my fiber optics cable. The idea here is you don't do very sharp corners because the fiber optics cannot bend too much. So I want a very curvy design for that. To do that, you can turn on the stabilize on the top, as you can see, and that way seems I quite know what I am doing now, but that's not the case. I am awful drawing and the lines are quite smooth at this point. I think that you do. Let's turn off the image on the background. Yeah, this looks like a brain. I can use that. Now I want to export that to my CAD program. To that I will export as a SVG, it's a curve format, and my CAD program is Plasticity. Plasticity is amazing, it's a very artistic oriented CAD program. And the drawback is Plasticity does not import directly SVG, so as you saw there I had to transform in step on that website, and I can import the step files. I don't know why these arrive kind of squished. Easily fix it with scale. Too much, a little less, yeah. This looks like a brain. One drawback is this arrived as several curves, as you can see on the left side, and I need to transform that in just one single curve so I can measure the size. You can select the curves and press J to join. Unfortunately, it's not working. So it seems when one curve intersects another, the join command does not work. I don't know why. So the solution I found, I will create several smaller curves without any intersection, as you can see. And now on the intersections, I will just raise a little the vertices so the intersection will not happen on the ground plane, as you can see. Doing that, I can now select both curves, press J, and it worked. So I need to do that on all intersections now. That done, what I want now is measure the length of this curve. Why I want to do that? Because I bought on the internet 5 meters of fiber optics, and I want this brain to use all the 5 meters. Actually a little less, because you know we need some error margin. So let's try something about 4.8, 4.9 meters. And with that, we can have the final size of our brain. Let's put some thickness. My fiber optics have 3 millimeters diameter. So in the end, I hope to get something like that. And I will have 2 points, as you can see on the bottom part, and I will use 2 LEDs for that. The challenge here is have a structure that will hold the brain in place. As you saw on the beginning of the video, the fiber optics cable is very soft, so we need something to hold everything together. And I thought using a hexagon structure where one hexagon can connect on the other hexagon with some connection system like a Lego, for example. So let's start simple. Let's create a hexagon. Let's extrude to about 5 millimeters. Yeah. And now let's work on the connection system. For that, let's start dividing the faces on the sides. For that, you select the face, you press Ctrl R, and this will cut the face. If I don't want a horizontal line, I want a vertical line. For that, you just press Tab on your keyboard. So I will get the middle size of each one, and this middle I will offset to create the shape I want to raise or I want to go inwards on the geometry of the hexagon. So now let's change to face mode, select the faces, and I can go inwards with the offset if I want, or I can go outwards. So no, I think this will be inwards. So let's change. Yeah, I think that work. I need to do 3 inwards and 3 outwards. Is that word exists? I think yes. Okay, so now I have the hexagon. I want to get an angle so when this is connected will not slip out. So just rotate about, I think 20 degrees will be enough here. Yeah, definitely will. And let's do that on all faces. Okay, that seems workable. Let's see if it's working. I will duplicate the hexagon and put more or less in place. Yeah, it's a perfect fit. And that's good? No, that's not good. Why is not good? Because I will print these pieces with my 3D printer. And in the real world, when you print like actual real pieces, they will never connect because you have the thickness of the filament, you have some error of the printer. So when you do something like that, you want the parts that will be inside to be actually smaller. So you have some margin to error to the pieces connected. So let's see now. I want to make sure all connections are right. So let's just move that a little. Yeah, as you can see, there are a small gap. Is that enough? I don't know. I hope so. Probably yes. So you have your printer, you know your printer and the what it can do. In my case, I believe that will work. Before do all the project, I will print just 2 pieces and test these connections, just to make sure. So after I do that, I will duplicate these pieces behind my drawing, so I can have an idea of how many pieces I will need for this project. Yeah, I can move a little, and yeah, I think that way it's missing now on the other corner. So some adjustments there. Yeah, I think that's good. Other thing I want to do, as I will need to print that, I was thinking in build on each piece the right support for the fiber optics. That way I will have a path where the fiber optics go, and will be much simple to keep the final drawing. The drawback of this approach is I will have to print the hexagons one by one and assemble them in the right order. Otherwise it will be a mess. So I want to create a tunnel where the fiber optics cable will go inside. For that I created these two circles. I will select just the upper part of these circles and extrude them. Yeah, I think that, and let's do the support. Select the face and extrude down. No, it's not what I want. So I think for that I actually need to select extrude on the panel, because I want this to go straight down to work as a support. Yeah, extrude. Yeah, that will do. So now I have to move this tunnel part to the top of the hexagon and position exactly where the fiber optic cable will pass. Let's adjust the rotation, 90 degrees. Yeah, more or less that. Just make sure that the base of the tunnel will intersect the hexagon, and let's rotate the right angle. Yeah, I think that will do. So now I just will duplicate that and put another one, and I will have to duplicate that over all hexagons in that project. Let's do that now. So as you can see in that place, my hexagon was too big and I had to squish a little in some parts. One thing I realized after I printed is this was kind of too thin and too fragile. And when I was assemble everything, I think I broke 2 or 3 of them. It still worked, but if I would do that again, for sure I would get them more stronger, like with thicker walls. Definitely I will do that. Done. That was a lot of work. So now what I have to do is export the hexagons with the supports. To do that, I need to keep that in order. So I am calling row A and the columns with by number. So I will export like A01, A02, B01, B02, and go on. After that, I will print one by one and assemble. Yeah, it's working. So what I need now is a box that will hold the electronics. The electronics will be basically the LED lights, and I want a switch to turn on and turn off. Very simple. The idea here is to keep using the hexagon design, so I will just transform one of these hexagons in a box. I don't need all connectors because the box will be on the bottom part, so I will need maybe 2 or 3 connectors. Let me check that. Yeah, will be 2. Okay, these 2 I will keep. And I need something taller. Yeah, I think that will do. Yeah, these are the sizes of my LED lights, so I am marking the position. Let's do a button. Yeah, that way. And the LED will go exactly through that part, so I can also carve the hole in the box where I want. And I need a support for the LED cylinders. So the first thing I thought would be a box, and I can subtract the size of the cylinder from that box, and I will have like a bed where the LED lights can rest in place. At least I hope so. On the top, it's easy. I made 2 circles and subtract that circles to the top because there will be the switchers to turn on and off the LEDs. And also I need another circle on the bottom part to install a plug that will connect the 12 volts power source. Okay, that's it. Now would be nice a system to keep this box. It's not a box, it's a hexagonal box. Yeah, I think it's a box. To keep this hexagonal box closed. And my first thought was using some cylinders and holes on each corner. That way I could just slide the top and the bottom. Unfortunately, that did not work. At least if you are printing with PLA, and this thickness I use here, it was just too fragile. So I broke in 10 seconds. I am showing now here what not to do if you are using PLA on that project. Maybe with ABS would work better. I didn't test, but with PLA wasn't great. So in the end, I changed, as you can see now, and I decided to use the good old screws. For that, I built 4 cylinders as the supports. And on the bottom part, I will position the cylinders on the right places. And I need to boolean to carve the cylinders out to make the holes on the bottom. And just to make sure the sizes are the sizes of the screws I have. And it's more or less that. Okay, that's the printed box. Nice. I used here PLA Black Mate, and it's not so shiny as you can see, and it's very good actually. I like the shade. Let's see if it will connect. Little more pressure. Good. It's working. So now the process will be get the fiber optics and go through all these tunnels on the right order, on the right places. You are not seeing now, but now I am looking at the monitor to see which tunnel is the right one at the moment. And one thing I realize is these tunnels are very fragile, as I said before. So I need to take care to don't break them from the hexagons. You probably can see now there's a good piece of fiber optics that I didn't pull and is still on the box, and that is not so good because if you remember the beginning of the video, I measured the fiber optics in the project and was almost 5 meters. So that piece inside the box will be missed at the end because the other part will not reach the box. As you can see now, and what I have to do is I had to pull out everything with extremely care to don't strap more pieces. So now the brain has shape and let's see if it works. Yeah, the light goes through all these curves. It's going dim as going, but it's working. And I have a solution for that. Let's start with the electronics. The electronics in this project is quite simple. I am using two 12 volts LEDs and I will connect that on a 12 volt regular power source. I am using here the black cables as negative and the red cables as positive. So first thing first, let's connect the power plug. let's bring the LED lights. They will be more or less here. Yeah, that work. And we have the switchers. So these switchers I bought and they have a light on them. Because of that, we will need to power them. So we will need to connect them with the positive and also the negative. If you are using switches like that, it's good to remember needs to be the ones for 12 volts. So these switchers are usually used on cars, I believe. So if you put energy, you can see on and off, and you have the light turning on and off in the switch. Yeah, and they will go there. Let's just check if they are perfectly vertical before click them inside. Yeah, with the lights on the top. And as they are round, I will use the bottom part to make sure they are aligned and vertical. Yeah, that's good. And we have the other one. Let's see if it closes. Yeah, still close. So I will use the same ground, the same negative for both, and the same positive for both also as a input voltage, the voltage that arrives from the 12 volts plug connector. Let's connect both switchers. Now I have both connected. I will connect the power from the connector. Let's do that. side. And my head's on the way. Yeah, oh damn, I disconnected one. Okay, that's fine. I will fix that in place and fix the others. Just a moment. In that case, I didn't prepare the cables before. It's important to heat well everything, so the soldering wire will flow to all connectors and cables. Yeah, that one is done. Just cut this piece that will not be used anymore. Tidying up. Yeah, that's good. Let's prepare this cable. Yeah, they are well connected. Now the LEDs. Let's just check that's the red one. And of course I want to connect to the button with the red light. And the other one will be the blue one. And I will connect with the button with the blue light. Okay. They can share the same negative, the same ground. And the positive, the red cable, will exit from each respective switch. All seems good. Let's test it. Nice. Red. It's working. Not bad at all. One thing we can realize now is how much power the system draws. If you look on the right side, you can see with both on, it's almost 2 watts. So your power source in this case needs to be at least 2 watts. When you get just one, is 1 watt. So depends if you want to build something like this, you know each LED will be about 1 watt of consumption. Let's tie it up and put all cables inside. I can say it's not easy at all to try to fit all these cables inside this small box. Let's try to tie them and see if it's easier. Oh hell, it's not working yet. No. Let's return to the project. So, I need some way to keep the LEDs on place when I open and close the box. I am thinking like a tunnel where I can slide the cylinders inside, and that way when I open the box, the LEDs will stay in place. The problem with that I am thinking is these LEDs have this metal enclosure, and I believe this is more for dissipation. So if I create a closed place to that, maybe I will have problems in the future. So maybe that's not a good idea. Instead of that, I can do the same thing, but instead of a closed place, I can build some walls on the shape of the LED. That way, we'll keep the LEDs in place. So let's make a try here. I will use Ctrl R to divide these faces. And the idea here is select the faces and raise them up. Yeah. So this should keep the LEDs in place. And this don't need to be too high, so yeah, can go a little down. And I have more space for the cables also doing that. Let's do the same here. Okay, that seems good. Let's see on the side view. Yeah, too high. Let's just a little down. Okay, that way will not collide with the top part. Doing that should work. Let's send to print. Let me just check if the material is right, because I was printing other things before. Yeah, always good to don't waste your time to double check your printing settings before you send to the printer, because depending on the material and what you're doing, there's a lot of difference there. I also like to see the preview before, so this is the path that will be printed. Okay, that's the new design. Is looking good, and I only need to change the power source because it's the only thing that's installed on the bottom. Okay, that's much better. Yeah. It fits. Good. I have to admit I also shortened the LED cables because I was trying to maybe save them for using another future project, but nah, that way it's much more easier. And the box closes. Wonderful. Yeah, I just need to screw to hold everything in place. But before that, let's connect the fiber optics on the LEDs. This LED comes with a plastic screw to keep the fiber optics in place, so needs to be extra careful to don't break things here. Close it on. That's the red light and the blue light. Wow, that's actually better than expected. And you can see the red and the blue mixing inside the curves. It's quite nice. Now what I want is a way to fix that on the wall. And as I don't want to drill holes in the wall, I am thinking something that I can use tape to fix in the wall and fix the brain on these supports. So if I get these circles more or less the shape of the connection between the hexagons and create a small cylinder on the edges, this hopefully will hold everything in place, and they are quite simple to create and print. Yeah, I think this will work. Let's do some. Checking, everything is fine. Ta-da! Let's see if this works. Yeah, it worked. And it's in place. Yeah, I think that will do. Almost there, so now I'll get this tape and just stick on the bottom of each one. So you are seeing this scratch on my hand. It's not from the project, this is from my cat. This is a very safe to build project. You will not get scratched in the process. I can't say the same about my cat. Well, that's it. I hope you liked the video. Before I finish, I have two important messages for you. The first one, and probably the most important, is please don't forget to like, share and subscribe to my channel. The second message is if you want to know more about the software and hardware I use during this production, I have all in the info part below. Thank you for watching and see you in the next video.